Hi, in this video we are going to discuss some problem for week 2 skill discussion forum, and these problems are very helpful for your assignments of week 2, including the MyMathLab homework assignments and the quizzes. The first question. So we are asked to find the domain. We are asked to find the domain of the function h of x is equal to the ln of x plus 6. Okay, so the domain is how far you can move on the x-axis, right? How far you can have the value of x that make the function to be defined. Now go back to the definition of the function ln. ln, remember, ln is the log function, the logs of base e, right? And then for any of the log function, we know that it cuts the point. It's going to the point 1, 0, and then it's going upward this way, right? So it's going, the curve is going to the point 1, 0, and then it's moving, increasing slowly to the right. Okay, so that is how the graph of the log or the ln function. Now we know that the domain of any ln function or the log function is always bigger than 0 and to the right, right? Nothing to the left of 0 or equal to 0. So this vertical y-axis here is the vertical asymptotes for the function, and therefore the domain is always from the right side 0. So not including 0. 0 is here. So something bigger than 0 and all the way to the right. Okay? We don't get anything below 0. So the same thing here. You can trick it this way. This is a function ln. So we know that the argument has to be bigger than 0, right? You don't want to get anything inside the argument of ln to be 0 or negative. Anything bigger than 0 is good. Therefore, x plus 6, you want the whole argument inside here to be bigger than 0. And then you solve for x, right? So subtracting 6 on both sides, you get x to be bigger than or minus 6. So this is the domain for the function. Or in the interval notation, we go from minus 6 and we want all the way to the right, which is infinity. Okay? Bigger than minus 6. Not including 6, right? Okay, we don't include a 0 here. Okay, the second question. We are asked to solve this following log equation, the log of base 2 for x plus 7 equal to 3. Now, solving this log is very simple. We apply the definition of the logs. We know that 2 to the 3 power is equal to 4x plus 7. Right? By definition, 2 to the 3 power, 2 to the power of 3 equal this whole argument here. That is the definition of the log. 2 to the 3 is 2 times 2 times 2, which is 8, equal 4x plus 7. And now, you want to solve for x, so subtract 7 on both sides, right? And then to solve for x, divide both sides by 4. So my x equal 1 over 4. Okay, the next question. Again, find the domain of the composite function in this question. So the domain of the composite function, and this function is given as f composite with g of x, and we are given that the function f of x is the square root of x, and the function g is 3x plus 5. Now you are looking for the domain of this function. The first thing is you have to write that function first, right? This is the notation for composite, but we do have to write out what is that? Right, f composite of g. We know that f comes first, so f is the outside function, g is the inside function. So that equal to f of g of x. And we know that g of x is given as 3x plus 5, right, for g of x. So I know that this is equal to f, and then g of x is this guy here, 3x plus 5. And now you are looking for function f, so we go back here. F of x is equal to the square root of x, right? So f of 3x plus 5. Now 3x plus 5 now becomes the value of x. Okay? So anywhere you see x, you have a new expression. So the square root of x, but your x is a new expression here, which is 3x plus 5. So this one is your composite function. And now you are looking for the domain of this guy here. We know that 3x plus 5 under the square root. Okay? So for something that is under the square root, you don't want this expression to be negative because you cannot have a negative under the square root. Therefore, the restriction, the domain for this guy here is when the thing below the square root it has to be bigger than or equal to 0, because you don't want to have any negative for the radical, or you don't want anything to be undefined, right? So all of this thing here has to be bigger than or equal to 0. And now you can solve for x. Subtracting 5 on both sides, I have 3x bigger than or equal to minus 5. And then dividing by 3, I have x bigger than or equal to minus 5 over 3. And that is the domain of your composite function. Or you can write in this form, the interval. So you want something bigger than minus 5 over 3. So from there up to infinity. Because we have the equal sign, so make sure you use the bracket. Okay. Next questions. Number 4. This one, they ask you to find the function f and function g such that f composite with g is equal to the big function h, and given the function h of x to be x squared plus 15 to the power of 3. Okay, we know that this is a composite function. So f is this can be written as f of g of x, right? So f is the outside function, g is the inside function. And you can see that, look at this function h. This one, we have this expression to the power of 3. So it looks like that the power of 3 is the outside function of f. Okay? And the inside function is this guy, x squared plus 15. So if I write this way, f, because f is the outside function, we are solving for f and g. F is the outside function, and the outside function is the outside power of 3. So something x to the power of 3. And then g of x is the inside function, which is this whole expression, x squared plus 15, right? You can check. Now, you can check this one. F, g of x is this thing, x squared plus 15. And then f function, we take this guy. We see that f of x is x to the third power. So f of this thing is this thing to the third power. So x squared plus 15. And then, because this whole expression go to the place of x, and then all of them go to the power of 3. So that's why we end up with the same thing. So this is the correct answer. Number 5. Okay, so we are given the two functions f of x. This equal to x to the third power subtract 7. And then function g of x is equal to the cube root of x plus 7. Okay, so now you are asked to find f of g of x. This is the composite function. Simple. We are given g of x already, which is this guy. So any time I see g of x, I can take the whole thing here to be g of x. And now I'm looking for f of this thing, and f of x is x to the third power subtract 7. So f of this thing, remember this thing now is the x in here. Okay, so anywhere I see the f function, I use this function here, and then now x to the third power, but x is this new thing, so I get, let me write this thing first, and then I take the third power, because this is the x, right? X to the third power, and then subtract 7. And the power of 3, the radical of 3, they cancel out, so no more radical. And then bring down to minus 7, and then they cancel out. You have x. Okay, now for part B, we switch the outside and inside function. G comes first, f comes second. Now g is the outside function. F of x is this guy, x to the third power, subtract 7. Now we are looking for the g of x function. G of x, so I follow this function, right? Okay, I'm looking for g, so I follow this function. The radical of 3 is still 3. The x, the variable x, now is this whole thing, which is x to the third power, subtract 7. And then I add 7. So add 7. You see that 7 cancel out. You have the 3, x 3. 3 and 3, they also cancel out. You have x. Okay, so my last question, part C. Determine whether f and g are inverse, yes or no. Now to check this one, to check if f and g are inverse, make sure that the two requirements are met, which is f of g of x equal x and g of f of x equal x. So we have that in part A, we have this in part B. So yes, so the answer to this one is yes. Okay, next question, question 6. We are asked to solve this exponential equation. Now we see that the exponential equation means that the exponents are now is the variable x, right? And then we see that they have the first one, the one on the left side has the base 5. This one, 25 can be written as what? 25 can be written as 5 squared, so that you can make the two bases to be the same. Now I keep the left side to be the same as given, and then 25 I rewrite as a 5 squared, and then don't forget that we still have the third power of x, and then I keep simplifying this one to I can bring it outside. Now because the base 2, the base 5 and the base 5, they are equal, and this is the equation. That means the left and the right side, they are equal. So the base is 5 here and here, they are already equal to each other. Therefore their exponents have to be equal in order to make the two sides to be balanced. Okay, so this tells me x squared minus 3 should equal to 2x. And then I can solve for x from here. I can move the 2x to the left hand side, and then making the right hand side to be 0. And I can solve for this by factoring. I can look for x and x to be x squared. I'm looking for two numbers. When I multiply together, I get minus 3. When I add together, I get minus 2. So 1 and minus 3. 1 times minus 3 give me minus 3. 1 plus minus 3 give me minus 2 coefficients. And then we can solve for this using the zero factor properties. X plus 1, you can set each of them equal to 0, x minus 3 equal to 0, and then you can solve for x, subtract 1 on both sides, I get x equal minus 1, and then add 3 on both sides, right? I can solve for x to be 3. So these are the two answers to this exponential equation. Excuse me. Okay, the last question, 7. Again, solve the equation. This one we're solving e to the power of x squared equal e to the 10x multiply 1 over e to the 24. Now before we can solve anything, we see that they have the same base a here, base e. So let's combine, let's simplify the right hand side. They have the same base, right, a, so you subtract the exponent because this is the division side. Using the exponent rule, I keep the same base, I subtract the exponent. And now because they have the same basis here, we have the same base e, they are equal. That tells me that their exponent have to be equal. Okay, and then I can I move everything to the left hand side. Subtract 10x and plus 24, making the right hand side to be 0. And then from here I can solve for x. Again, by using the factoring, I can have x and x. Finding two numbers, when I multiply together, I get 24. When I add them, I get minus 10. That is minus 6 and minus 4. Minus 6 times minus 4 give me plus 24. Minus 6 plus minus 4 give me minus 10. So that tells me that I have x minus 6 equals 0 and x minus 4 equals 0. And adding 6 on both sides, I have x equals 6. Adding 4 on both sides, I have x equals 4. And that is the solutions to this exponential equation. Okay, so that is the end of this week 2 discussions, and thanks for watching.